All right, another stream getting started. Oh, Tuco's here. Hello again. So, actually, that's usually the cat camera, but right now it's showing the contents of the stream. So, today I actually need to help. Well, hey, Tuco. Cat was apparently mad at not having the attention. Anyway, yeah, I got this box of these D-Link cloud-connected cameras, and these are actually for a class that some of my coworkers are doing soon, and I'm helping them out with some hardware modifications. It's a short class, and they don't really have time to get into the hardware side too deeply, so I'm doing a little bit of prep work so that the students in the class can just attach a UART to some exposed pins without having to go soldering on the circuit board. So, I think I'm going to dig into one of these and kind of see what's going on. The main objective here is just to do the hardware modification, but I also wanted to get some kind of documentation footage on the process since we want to show the students, what it was that was done to these devices before they got a hold of them. So, so I'll be trying to get some video footage that I can put together into something like that. Oh, there's Tuco with his bolt. Oh, that wasn't one of the ones he likes. Sometimes he finds a plastic bolt that I printed in a material that he's not too fond of. So, let's take one of these over here and see what we're dealing with. All right. Cat cam. Happy Tuesday, everyone. So this was actually supposed to start yesterday morning. This was like an early morning FedEx delivery, but I guess either they didn't manage to find my place or they managed to try to deliver it during the 10 seconds I was out to grab a coffee. So I ended up waiting around for this and mostly doing CAD yesterday. And today we can actually get started with this. And so I'm going to take apart one for kind of investigative and possibly filming purposes. Since it might be nice to get some footage where I'm just working on one at a time, but then I feel like a lot of this I'm going to want to kind of assembly line as much as possible, especially the mechanical parts, since this is going to involve soldering some magnet wire onto the circuit board, epoxying a little bit of 0.1-inch header, something that's easy to plug tools like these little kind of universal serial adapters into, so then there's some mechanical. There's a magnet here. What is that for? Oh. It's tempting to take these magnets for myself. You don't really need a neodymium magnet in the case there, do you? It's glued in with some kind of red. There's like a little bit of red residue there. Interesting. First hidden feature, a neodymium magnet included in the packaging. I'm sure the cardboard recycling folks enjoy that. And then I have it upside down, of course. Alright, so here's the cloud camera we're dealing with. You can see IR LEDs and all that. It looks like it might rotate, but it probably doesn't. I guess that's probably just a lens. It's kind of a cute little thing. So, it does look like the circuit board is flat in there probably. Let's take this off. And looks like for most of these I'm not even really going to have to open the box any further, but I might take the power supply. Well, I won't worry about that now, but I might want to power on one of these just to check the serial connection, or take one of these adapters out so I can check each one, you know. All right, my phone is going to keep beeping unless I acknowledge that I looked at this text message. All right, so here's the thing we're dealing with. Ooh, that is some glare. That's more like what I wanted. We are still servo AF. A little kind of protective lens over the actual lens opening. It's interesting. Nice brass insert for the tripod mount. So it looks like it probably just snaps open around the edges. I'm feeling for signs of a screw. It looks like there might be one in the middle here. Can feel kind of an indentation there. Let's maybe hunt for a screw. I'm almost certain that's a screw. Just going to poke that a little bit. Maybe that is a molding defect. I mean, not like a defect, but every time they injection mold, you have usually several things that you have to cover up after the fact. And I think that's maybe the port where they injected the plastic. Okay. Well, I think it might just snap apart. They did a good job of hiding the seam. It's hard to tell which one of these is the real seam and which one is like a false seam for just hiding the real one. I know that my coworkers have done this before, and I think they even have documentation on it, but it's kind of fun just figuring this out. There might be something I'm sure that this project is going to involve cutting into the plastic, and so it's possible that that it might be easiest just to do the cutting and then do the soldering once I know exactly where the thing is. Let's take a closer look at the seam. I was also keeping an eye out for the cat. I don't actually see him. So, I wonder if they, wonder if these are intended to be any kind of weatherproof. Doesn't really look like it, but the seam is nicer than it seems like it would need to be for just a purely indoor camera. Maybe the microscope would help. I think I've actually finally got the stream chat in a place where I can see it, so I can actually see Kenneth. So hi, nice to see you here. That's interesting. That doesn't seem to actually be the seam. And maybe it's just this one. don't know if that's actually a seam. That's a closer view of that thing that seemed like it might be a screw, but is actually just a molding injection port. Is that a seam just in the silver part? So I wonder if that's glued together and then painted after the fact. It's very weird. It's just, don't know what part of the manufacturing process causes this silver coating to happen, but it seems kind of suspect. Oh, is that not it? Yeah, that coating is not very deep for sure. That seems like it might be a seam. Or possibly I'm just cutting into the soft plastic. I mean, when it comes to actually modifying a bunch of these, the Dremel is one option. I think it might even be faster to use a hot knife, which in this case is like basically a soldering iron with a flat tip on it. Oh, that feels like I got in. Huh. Let's change this microscope slightly. Oh man, that's one of the weirder noises around here. I don't know if you could hear that, but there's like a trumpety kind of noise. That's actually one of the food trucks around here. When they drive by the nearby construction sites, they let folks know that breakfast's available. Let's try to get a better view with this camera, because that's not really working. Why? Oh, this clamp. Okay. Oh, yeah. A lot of people have have said in chat that they would be at destructive entry by this point, and yeah, maybe I would be if this was some random thing I was cracking open and not something I was trying to keep vaguely presentable. Part of the spudger is much sharper than other parts. I think this is the sharp side. Let's have that go into plastic and not in my thumb. Actually, I think I just need a stronger kind of pry bar thing. I think there's enough of a gap that I can just kind of try to gnash it open by the corners. This tool, maybe? Oh no, that wasn't very good for my tool. Metal tool then. no screws in the corner that I've missed? There's nowhere for screws to hang out. I mean, I assume that this faceplate is stuck on with clips, and then there would be screws underneath this separate faceplate piece. Oh, maybe we're done with the microscope for the moment. I don't want to make everyone nauseous. Oh, nice. I think I just needed less microscope, more elbow grease. And this metal spudger helps a lot. Definitely going to look for a way to not have to do this to each of them. I think I'm just going to try to melt a hole in the case where I need it, and then not actually bother opening this. That could have been bad. Not slice my thumb off. I've got a couple of these corners unlatched. Oh yeah, you can start to see what's going on. These are just kind of little ferocious little plastic snaps holding this front faceplate on. No glue, it seems, which is nice. Just ferocious little snaps, which is, you know, good design. Let's try not to impale the circuit board while I'm at this. So there should be basically, it's a footprint on the circuit board that I think it was originally designed for something like a flat flex cable. My coworker sent a handful of surface mount connectors they thought might be close, so I was going to try that just in case. But I think the main plan is to just cut a hole in the case for some 0.1-inch headers and then epoxy those to the board and run magnet wire where they need to be. Okay. Oh yeah, some of this plastic is definitely kind of toasty. Sorry, little snaps. This will rattle a bit. Okay. Yay. Wow, there's like this whole seal over the brass insert area. That's interesting. And, that's pretty simple. Yay, and then these are the goodies. Let's, do that. Neat. So, RE-Link, I think that's just going to be the Wi-Fi chipset, but maybe that's an SoC, I don't know. I guess with a device this integrated, that's probably an entire SoC. And I mean, that would explain it being connected to what appears to be some external DRAM. Just out of curiosity. So this board is now held on with one screw. Great. I guess I need to get a screwdriver. Oh, there's Tuco. I couldn't find the cat. He was on the heating pad. Can I zoom into him a little? Focus. Oh, that little guy is into the heating pad. Well, I'll be right back with a screwdriver. There's got to be some rule about it always taking longer to find the right screwdriver while you're on camera. I don't know if that's true though. Sometimes I get lucky. So It'll also be nice to have some microscope footage of this board, and you know, I'm sure you and I will be interested to see in detail what's on it. So that screw out. Ooh, there's a wire. Ooh, that's for the IR illuminator, it looks like. Does that have a built-in, ooh, there's a VGL, ICR, and IR. So I assume that's IR transmitters, and then is this a light sensor or an IR sensor or something like that? Maybe that's a daylight sensor, like a light sensor behind an IR filter. And then that's the microphone, I guess. ICR. Oh, that is the microphone, but it's down here on the main circuit board. I see. Oh, buzzer. Huh. Interesting. Well, so we have... I am slightly curious to just take that off too, just for completeness. Oh, that is not the right screwdriver. Wow, Tuke's comfortable. That cat. Off the hook. This is the wrong kind of screwdriver, but oh, it is so close enough. If I cover it up with my thumb in the video, no one will know it's the wrong screwdriver, except for sticklers. So... Okay, so I'm just taking off these three that look like they might hold it down to the plastic. The two in the middle are almost certainly to hold the lens. Well, not the... So I think that's like a protective cover, basically. Oh, I wonder if that's an IR filter that can flip into place. That would actually be interesting. Some cameras have that, like a little actuated IR filter. I wonder if that's like an LCD thing, or if that's just a passive piece of filter glass. Oh man, that is totally an active IR filter. That was worth taking apart. Oh, so that's what ICR is. So, oh man, I kind of want to try actuating that, because that looks fun. Let me unplug this from the main circuit board. Okay, let's put that aside. Restart the camera thing. Oh, hey, Tuco. Didn't mean to kick you in the back. Okay, what do we have here? This is fun. So, man, imagine the potential for annoyance if you, you know, if you break into one of these devices and take over the firmware. Not only do you have whatever that little buzzer is, you could just make this thing flip open and closed incessantly. So, nice big copper pores for the current carrying traces for these LEDs. It's a kind of elegantly designed little board. So what do we have back here? So it looks like the drive circuit for both the LEDs and the this coil thing are actually on this board. Let's take this under the microscope. In a recent stream, I cleaned that button pad that I used to switch cameras, and it's working so much better now. So, okay, so let's try to get a bigger picture view here before we get too deep in. So here's the input. G for ground, V is probably your power supply voltage. It gets filtered through an inductor, and then you have a bunch of local power supply decoupling capacitors here. It also looks like they're starting their LED string there too, so the LEDs are probably driven with a bunch of them in series and then pulled down with a MOSFET. So it looks like that LED, and then yeah, so we're kind of, that is like a photodiode sensor, I guess. So this circuit's probably an amplifier for that. I assume they're using this to detect sunlight, but that's interesting. I wonder if you could also use this to pick up modulated signals. So what else? VG. So IR, I assume, would turn on and off the IR LEDs. Can we see where that goes? Not really. But it might actually just be power for the IR LEDs too. Maybe that goes directly to this. Well, we can check that with the multimeter if we feel like it. L. So I assume that's a light sensor. That seems to be, so that's one of these transistors. So that assume that's like an open drain output from this circuit maybe. And then I assume ICR would be driving like some kind of a bridge circuit that would flip that coil one way or the other. So these might be inverters or buffers of some sort. It looks like maybe a couple of small logic chips driving a pair of transistors, like a half bridge maybe. That seems fun. This is actually where that coil plugs in. So I don't want to like power this driver without understanding more about what voltages it's expecting, but I do kind of want to just try actuating this with a power supply just to see what we're up against. So I'm just going to try giving it little pulses from a signal generator just so we can watch it actuate. I think that would be interesting. On top of something so we can maybe see the filter more clearly. And so right now it looks pretty clear. Oh, do I have anything that'll fit in here safely? I think I can just put two very fine wires in there. Or by very fine wires, I mean fairly regular size wires. They're actually not that small. Here's one that's like probably 26 gauge or something. Maybe that'll work. Yeah. So let's see what the coil resistance is. .2? Really? Am I getting a short through something else? That's more like it. 17 ohms. That seems like the kind of resistance you would want on a little coil like this. My signal generator isn't actually set up right now, but I'm just going to try tapping it with my power supply. I know this is a bit of a diversion from actually the task at hand, but I've been curious about these for a little while. I haven't actually taken apart a camera that has this mechanical shutter on it. I just heard them click. Like, there's a camera in my machine closet that I don't use that much, because it's one of these like kind of sketchy cloud cameras, but it seems to have one of these also. So I'm going to turn the voltage down to just like 2 volts. So let's see what this is like. I'm gonna try, so this is just 2.5 volts. I'm just gonna try forward polarity first. Doesn't seem to do anything. It draws 150 milliamps, but I don't see any motion. So I'm gonna try the other polarity. I can kind of hear something, but I don't see any movement. I'm going to try cranking that up to 5 volts. Oh, that definitely switched it. Let's try switching it back. Nice. Well, that was fun. We can actuate the little mechanical IR filter. So this board does seem to have a light sensor, IR emitters, and an IR filter. So I'm guessing the light sensor with the IR filter is mostly detecting whether there's significant IR content coming in, and then using that to figure out whether to actuate the filter or not. So that would really be an issue for daylight mostly. So I assume this is designed as basically a daylight detection diode. And it's got like it's the photodiode with this little filter heat shrunk on top of it, I think. Or maybe that's molded into the photodiode enclosure and the heat shrink is just to keep the light out from the sides. So you don't want to be measuring these diodes necessarily. All right, that's fun. Let's move on. So that can hang out in here. Put those screws back. Now that we have probed this part for its secrets and no longer need the secrets, and being back in one place would be kind of helpful. And that explains why there's kind of a lens mount style thing on the back of this circuit board. Is this camera feeling servo AF today? Oh, this one certainly isn't. Oh, I think he just looked over to see the heater start up. I'm not being very gentle with these screws. I don't think this is going to need to come apart again. Okay, well, front's back in one piece. Now let's take a closer look at this board. So Here on the backside, that seems to be the camera processor. Let's see. Yeah, so you can actually see the bus going from the camera module itself, which is this dinky little thing here. I've actually got it glued to the board. So it's probably some kind of surface mount module with both the image sensor and the lens integrated together. And then this little bus actually gives this little bus brings the raw image data over to this chip, which is probably doing the compression. And it's probably kind of a general purpose camera front end like you'd find in a webcam, but not sure what interface they would use to attach this to the processor. There's several options. Seems like it might be doing microphone A to D also. It's kind of hard to see where the microphone goes, but that looks like a switching power supply. There's some serial flash, WinBond. That might be something that's fun to read out. Probably has configuration settings for one of these chips. Or that might even be the program flash, like maybe it boots by copying that into RAM, I don't know. Another switching power supply down here. There's one debug header. I don't think that's the one we're looking for, though. What do those labels say? G, R, T, and V. I think those are just power. Or are these two traces? Oh, that is something related to this flash chip. So we have a 25064, or 25Q64. Don't know how big that is off the top of my head. Maybe that's 64 megabits or 64 kilobits. Here's a close-up of that camera processing chip. Gooped up camera. So I think the interesting stuff is going to be on the other side. So if everything interesting is on this side, then that means I don't even have to take these out in the future, which would be nice. Oh, here's the Wi-Fi section. Oops. Oh, maybe I will go back here. So we've got a chip antenna, which is nice. They decided not to design the antenna on the circuit board and instead went with a little surface mount chip antenna plus a UFL here, which presumably they would use for development and characterization. And that all goes right into the system on a chip, which I assume this has also got the application processor in it. But well, this is interesting. This doesn't look quite like I was expecting it to. I remember seeing a photo of the connector that I am supposed to be attaching this to, and I don't see that. Let's see if we can find any documentation for this chip. Oh, getting a comment, or US Water Rockets in chat says that that connector I was just looking at is RxTX ground, that RTG. Yeah, that would make sense. I mean, we can try that out just to see if that has serial. It's just that looks like it's going over here to the flash chip, but it's possible that that just is where those traces are routed and it's not actually connected to that. Because I kind of expect that this might be SPI instead for programming that flash chip. Maybe I will briefly refer to my notes to see if I'm just missing something obvious. Oh, and Zuko moved. Laptop. Yeah, I know I saw a photo of this connector, and I'm just trying to remember where. Okay. You know, this looks like a different revision of the board. I wonder if that's real. So I can see that partially up there. Yeah, I mean, let's boot this thing up and just check to see what's on this header, because it could be interesting. Yeah, I don't have a lot of documentation from the last time they did this, but I have some photos, and the photos look really different. Like there's I think I'm holding this in the same orientation. In that photo, there actually would have been a big flash chip right here, and the connector would have been kind of over down here, and it's definitely not this connector. Like this, I mean, it's not the same footprint that I see in the photo. So like this connector looks like kind of a JST box connector style, whereas the one they attached the serial header to previously looked like a flat flex connector. Or something more like this, like a horizontal mount, surface mount wire header or something like that. So I might not be able to just copy the last method for doing this. The two things I will look into, so I'll power it up and look at this header. I also will just see if I can find anybody's pinout for this RA link chip and just see if I can find out where the UARTs go. So got a couple of ways forward here. US Water Rockets in chat is saying that RA link chip is a router chip and not an application processor, which is weird, but I'm just going to take a look at some of these data sheets myself. Because I mean, either that's the processor or the one on the back is, which is certainly possible. I just would have expected the one that's directly attached to the DRAM to be the application processor, you know? And I mean, just because it's a router on a chip doesn't mean it isn't the application processor. That actually probably means it is, because, you know, if you look inside a router, it's basically a little Linux board with a bunch of Ethernet interfaces and possibly some hardware-assisted routing. But Yeah. Yeah, this RT3352 is it? It's a single chip wireless access point. So it's basically that with a built-in, probably like USB or parallel camera. UART, 40 megahertz crystal. Is that what we're dealing with? 40 megahertz? Kind of curious, not that it really matters. Sure. Ooh, that's even labeled. Oh man, I wonder if that's it, actually. That looks like it might be what we're looking for. That's either that or JTAG. But yeah, anyway, let's maybe try to find out what pins we're looking at. Ooh, that could be it too. If I were gonna bet, I would say that's probably JTAG, and that's probably serial. But if we can figure out what pins we're looking for, we can actually probably guess which one's which just based on the board layout. T3352. Yeah, when I say JTAG, that could certainly be serial SWD. So, and it may or may not be. Like, there's no reason for them to use the standard pinout, so I wouldn't really assume that it is. Man, it's just a minefield of grossness all over. Most of these are probably not actually data sheets. Huh. No. Alright, I'm just gonna get out the O-scope and start probing around. Let's see. How much put back together does this need to be? Oh, I've never seen an Ethernet transformer quite like this one. It doesn't have any markings on the top. It was epoxy filled from that side instead. It's interesting. Alright, let's have the insulating pad here. And what is this? Oh, 5 volts at 1 amp. I'm just going to run this from my bench supply. I'm not even going to bother. Just had to double check that it's center positive just in case something terrible is going through their mind. Oh, where's that test lead? Oh. I was looking for this little cable I made. It was still attached to my other test setup. This is not long enough on its own. keep the tiger in focus. It's one of the primary jobs during these streams, you know. That's fine. All right. Boots up just fine. And blue LED shines right into the microscope. Let's get the scope booted up too. Where does that live? Oh yeah, that's printing out fine. Nope. Oh, yeah. Almost didn't recognize that without the scope actually there, but I guess the VGA doesn't turn on until the scope's actually finished booting. Aw. There we go. Good old scaler. So, what do we have? Let's get a ground from over here, because that should be fine. And let's not have 10 volts per division, maybe. Okay, so does this have an easily accessible reset button? I assume it's one of these. This is labeled SW2 and what I assume is SW1, but I don't actually see the label. So if I push this, nothing really happens. If I push that, nothing really happens. Well, nothing immediately. So I assume neither of them are hardware resets, which is what I want. So I'm just gonna power cycle this and look for something happening on one of the I/O pins. I think I turned it off or something. Anyway, let's kind of want the scope and the microscope at this point. Okay. Okay, I've got this little cluster of 4 pins in my site. Let's actually put this board in a vise. This tape is not cutting it. So these look more like test points than serial ports, but, you know, let's try those anyway. I think those left two are connected to each other, and hard to tell what the top right one might be ground. And then there are those 2 other nearby test points. And then we have these. Looks like at least 4 of those are running to the processor. So let's try all of those with the scope and see if we get any good data or anything that looks like maybe serial. There's also no guarantee it's talking on the serial port when it starts up, so this isn't conclusive, it's just the first thing to try. All right. Let's start out with these 2. This is idling at like 1.5 volts. What is that? Yeah, so that could be a GPIO for sure. Let's try capture a little slower, and then try power cycling. Yeah, could be a GPIO, not necessarily a serial port, but there's that little glitch, and then it's idling at 1.28 volts. So this one, I'm going up to the next kind of top left pin. That one should be the same. Yeah. Top right is idling at ground. I think that's just a ground. And bottom right, a little glitch when I plug this in, but then it idles at ground. So those probably aren't it. I'm guessing those might be like selection jumpers for something. Then we have these 2 test points, which not likely, but I'll try them while I'm here. Another little blurb when it starts up, but then it idles at ground, which a serial port wouldn't do. That's interesting. That's probably some other GPIO signal that goes through different states as it boots, but doesn't seem like what we're looking for. So other side of the processor, the little port. Let's try those 4 that are closest to the CPU. So there is the top one. Looked like a couple of little blips when I turn this on or off, but it doesn't look like data is happening. Second from the top. Similar. Third. That's more promising. That's just 3.3 volts, but it seems to show up very shortly after I power on. And last one is also idling at 3.3. seems to come up pretty straight. Doesn't seem to have data. Oh, nothing other than 0 volts on the left side so far. Let's maybe scroll around under the microscope and see what else looks interesting. So we were just over here on this little connector and on this connector and the 2 test points near it. I mean, it makes sense that the serial would be accessible somewhere for development, you know, unless they were really paranoid about not including serial. Oh yeah, we were going to check out the pins next to that. The ones that looked most obviously serial, but seemed to be going into the flash chip. Let's check those out, of course. So, I think those were a little easier to read from the bottom. Let's see if I can do this. It'd be nice to have a right angle barrel plug for this. I put a vise in your vise so that you can clamp while you clamp. Two pulled down resistors. And then they go over here. Well, let's see what we got. All right, so still powered on. So this should be ground. Yeah, this should be power. 3.3 volts. 3.3 volts. And ground. Well, let's see if this actually has serial data. Oh, I think this is what we wanted. All right, well, totally, I didn't want to believe it was going to be this obvious, but yeah, I guess that's the thing. So this could probably even be like a little JST style wiring harness kind of connector. Let's take a look at that data on the scope from this pin. I guess it was also just misleading that it was going over here. Is that... I think it's just going to end up going into one of these vias. And it's kind of roughly on the opposite side of the board from that RA-Link processor, but only roughly. So, okay. Cool. So, T for transmit. Cool, so power off, power on. Ooh, look at that. Good data. All right, we could take a look at what that says, but I think we'll get to that later after we break this out. We'll just try attaching a serial dongle to that, just like the students will be, and we can actually see what it's saying, but I assume that's just going to be Linux booting messages. Like, it seemed to kind of have the cadence of Linux trying to boot. So, all right, well, that is a slightly different connector than what we had on the other model, but at least it doesn't seem like they actually made it any harder. So, we're in good shape. So let's see what we can do mechanically for making this available without having to take this very much apart. So that fits in here. And that normally just sits in there. So it seems like I could just go in with the hot knife, like right here, or even possibly a drill press, and just cut a little hole in the case right there for the wires we need. And my main question is it easier to go in through the front or the back? I don't think it really matters for our purposes. So I think I might do one of these just with the whole thing disassembled like this, but with an eye toward it fitting in a case that's been very minimally disassembled. And then I'll see if I can do the rest of them without actually even having to take the case apart, because that might be the most time-consuming part of the process even. So mostly just thinking about fixturing here. Like if I have this clamped into my drill press, clamped that way. I mean, I guess it makes a little more sense to go in through the back since that's not as curved and doesn't leave quite as obvious an entry wound. So that would just be drilling through this part of the plastic, just enough to get through the plastic, and then I can basically just shove 4 little wires into these holes, solder it, and then epoxy that header down to whatever's convenient. So either the board itself, it's less good for anybody who wants to open it if I epoxy it out here, but it's a little easier for people to work with, so that might be a thing. And just being serial, I don't really have to worry about making the wires super short. So I think that's the plan. Noticing the I'm just catching up on chat. US Water Rocket says, I label all my test points self-destruct and erase all. Yeah. And then Kenneth suggests maybe just epoxy the header on the board and then hot knife to expose it. Well, that was my original plan. I mean, I guess it's just the order of operations. Like, I would prefer to hot knife first, since I think if I can do all my work through that aperture, then I don't have to actually open it. So then it's just a question of how big of a hole do I want to make. So maybe I should just take another unopened camera and see. I'll just try out the hot knife approach and see if that seems like it would be easier than using the drill press. So let's open another camera and warm up the tool. This is the hot knife I was planning on using. I think it's actually Weller brand, yeah. Just like Weller brand sold in arts and crafts stores, not the soldering, or not the electronics department. And that'll take some time to heat up. Fresh camera. So we should be able to basically just dig into this area right there. And like, I don't think there's anything we can damage there. It's really just a matter of how messy the results are. You're not ever gonna autofocus. There we go. So yeah, it'll just be right under there. We can just make a hole. Let's see how annoying it is to make a big enough hole. Yeah, Phil in chat points out that the drill press leaves a lot of plastic chips, which is definitely annoying. So the hot knife avoids that. And the Dremel, I don't know, I feel like the Dremel is kind of the worst of both worlds for this, because you'll end up melting the plastic, and you'll end up getting dust and chips everywhere, and you'll probably end up breaking a few cutting blades. The knife is getting hot enough to burn whatever was already on there. Also good to do this in an area with plenty of ventilation. Maybe even I'll turn on my smoke absorber fan. So it's just getting an idea of how far over I have to go. So there's, well, if I cut out about as far as the made in China, then I've gone far enough. So let's try that. Oh, I think I need less visual contrast in this. It's way too dark. Maybe I just take the metal piece out. Okay, there goes nothing. This is kind of like the most disgusting cake. Well, that would be just barely enough to solder. Let's see if I can. This is actually really easy. I might just not worry about making the hole super small and make it a little bigger. There's a plastic snap I'm going to end up cutting through right over here, but I don't think that's a big problem either. I guess I can go right through the label too. That's nice. Hot knife through router. Well, camera. Pliers. That's cool. With the fan running, I can barely smell the stench of burning plastic. That needs more cutting. And more servo. Okay, that's pretty spacious. So I think if I do that, then I can solder the wires, kind of push them against the board a little bit, then epoxy the connector to that area of the board that's exposed, so that now if you want to take it apart, you can still like spudger it apart and probably get it off without breaking anything. But you still have easy access to the connector without taking it apart further. So I'm kind of happy with that. Well, it's tempting to do more of these while the hot knife is hot, but I think I want to go through with this whole process on one before doing the whole assembly line batch thing, so I'll go ahead and unplug this for now. Cool. Lots of good suggestions for how to do lots of these. But yeah, I don't have to do that many. It's like 30 maybe. So let's just test one. But yeah, it'll be easier to do when I don't have to mix all the epoxy a little bit at a time. So I'm gonna get the magnet wire and headers. Magnet wire might even be exceptionally fiddly for this. I mean, I could just use Kynar, like wire wrap wire too. But I've got plenty of magnet wire here. 32 gauge. So I think, oh, this might even make sense to use my solder pot to tin a bunch of these wires. Use all the weird tools today. Well, do I want to do that? Do we want to use the solder pot? Let me just do this first one with this technique, but I'll think about using the solder pot to tin a whole bunch of these wires quickly. Oh, very good question from chat. Why not just mount the connector? Well, I don't have the connector. I mean, I could order a bunch of them, but we're already kind of a little tight on time with this project. The other thing is, we don't necessarily want... Well, I mean, basically there's always the option of like fabricating something for this particular purpose. Like we can make a connector that goes from this thing to, 4 leads that people can just plug into stuff, and that's totally an option. But like usually that's not going to be worth it for this kind of one-off job. I don't know, it's like this is a class where there's a bunch of instances of something which would usually be a one-off job, so it's kind of weird. I thought about making a little adapter, a PCB kind of thing, but yeah, again, I don't know. It's always a trade-off between time spent on the tooling and the actual thing. So, well, I think I can at least save a little bit of time by attaching these wires to the header all at once. Let's try that technique here. And these are terrible tweezers. So this is probably going to be more magnet wire than I actually want, but I will cut off the excess after kind of pushing it through the holes, and having a little bit extra will help me get these lined up. So then I think I might try doing something where I tin and solder these to the header all in one go. At least for the, before I get out the solder pot. I mean, I don't know if that's going to work, because this, I mean, tinning them with the soldering iron usually only really works if the very end of the wire is exposed so it can get hot enough. Whereas I also kind of wanted to clamp it onto this. That's not working. Yeah, that is annoying. I feel like theoretically somewhere I've got a wire wrapping tool. Oh. Maybe a little breadboard to hold the other side of the wire while I solder it. Yeah, maybe I'll see if I have that wire wrapping tool. It would be in one of these bins. The wire wrapping tool usually gets mixed in with the little screwdriver since it looks so similar. Nope, that's a screwdriver. Ah, man, this thing looks old. I think I've got a fancier wire wrapping tool around here somewhere, but this is my main one. Ooh, is it clogged? That might be bad. This wire wrapping tool has some junk in it. So these are pretty neat. They're really old school, so you might not have seen one of these before, but if it would ever focus. So, looks a lot like a screwdriver, but there's a little hole in the end that you stick over a wire pin, and then there's an even littler hole next to the edge that you stick some 30 gauge wire in, and it helps you twist it around the middle wire. Except I think there's a piece of broken off wire in that hole, which is not good. to push it back enough that it doesn't get in the way. Man, I wonder if I can solder to it. It definitely seems to get in the way of using this tool, but maybe it still works barely well enough. So Kynar wire, I have that over here. So strip off some of that. That goes through there. And it's supposed to sit flat down on what you're wire wrapping, but this tool is kind of jammed. That is totally serviceable. So, and then the other end can just solder to the board. So, yeah, I think that'll work out. Let's have some small pieces of that. Oh yes, also from the chat comments, this is more like a mailbag item, but just got this as a gift from Kenneth, who's in chat, so thank you very much. This is a micro soldering handpiece, which I think might even be a little overkill for the kind of work I'm doing today, but this will come in very handy for some of the really detailed stuff that I do here. So this looks super exciting. This is an add-on for the recent soldering iron upgrade. So nice little 24 volt, super little tan piece. Yeah, that. I didn't even know you could get soldering irons like this, so that is very much appreciated. Okay, so I'm going to do more like assembly lining this once I get one of these tested, but for now I'm doing this kind of the slow way. At least I'm hoping I can speed this up some more. So strip a few more wires. Can we have camera? Just don't have time to do the manual focus this entire time. Somewhere I've got a fancier wire wrap tool that has like a hand, like you squeeze it and it has like a gear train that wraps the wire for you. Sorry for the loud noise. So, those are on there pretty well. A little header with some wires. Now I'm just going to cut these all to the same length. I really don't have a better way of stripping 30 gauge wire than this thing, which is a little annoying. You know, I used to, when I did a bunch of wire wrap, I had this little tiny little metal thing that was just like a little sharp piece of sheet metal. It didn't really look like a wire stripper, but it worked alright for 30 gauge. It didn't really work alright enough that I would go seek out another one of those tools though, because it also kind of sucked. So I think I just ended up making one of them shorter because I broke it and had to re-strip it, but only very slightly so. So it's a terrible place for that. Oh, that's not hot anymore, thankfully. So yeah, I think for these I'm going to put a little bit of a kink in them so that I can bend them separately if need be. And then tweezer these each into the right hole. So I will, on the ones that don't have access to the bottom side, I'll have to be pretty careful with not making these wires any longer than they absolutely need to be. So something like that, and then I'll just go in and solder it from the top. Oh, this is the huge tip. I will switch this before doing the next one. That going anywhere? Is that just like soaking into the ground plane on the other side? Ugh, this is terrible. Let's switch this. I don't even think I'm going to use this footage. I might do the other one slightly differently. Oh yeah, a good question in the chat about why I'm doing VCC. And yeah, it's not necessary, it's just kind of part of the training. Like I would want them to have this, like part of the training is figuring out which pin is which. So like if I was doing this just to make things like absolutely easy for everyone, I was thinking I would just like solder on like an FTDI standard pin out, but that doesn't really help with the step where you need to kind of figure out your own pin outs. And it'll be a little harder to do that maybe without the board accessible, but I think, you know, I think the kinds of techniques people will be using are more like using the multimeter to see what resistances and voltages are on those pins, and less actually tracing them out. And in this case, it didn't really help, because like, look what that got me. I traced it out, and that led me down a false path, because I thought it was to do with the SPI flash, and it turns out, nope, it's just UART. So, it's put a different tip in here. This one. Oh, maybe this one? Yeah, this seems fine. Yeah, because I don't necessarily want like the absolute tiniest tip for this, since I do actually have a lot of stuff to heat up. But this one seems fine. This is like the tiniest non-micro tip. put that in right? It'll tell me in a sec. Yes, great. Warming up the soldering iron tip. Alright, let's also put this in something. This is kind of grabbing it by the front lens assembly. It's not so great, but it's better than literally nothing holding it. Oh, that's much better. Yeah, I'll probably do this, well, because the video that I want to make about this isn't about the assembly line process, it's about how to do this to one. So I need to make sure that I get footage that's relevant to that, but I also don't necessarily want to do them all individually. So this is the ground plane for sure. This one might benefit from the slightly larger tip. But I'm not super happy with this particular run of it as far as this one being educational. Yeah, I think I might need the slightly... Well, let's try just raising the temperature a bit, if I remember even how to do that. I actually have no idea how to change the temperature on this iron right now. I've just been using it at 750. Briefly read the manual, and I'm trying to recall some of that knowledge. Let me just hold it there longer. Oh, there's a good question from the chat from Sodium. What is the purpose of that copper island in the corner? And that's a fiducial marker. Usually you have something like this on every layer so that the machines... I mean, I don't know whether this one specifically is used for assembly or for board manufacture, but definitely the assembly machines will look for these in order to optically register themselves to the board. And I think earlier in the process they can stick that on the exterior that ends up being cut away from the panel, but yeah, this isn't working. I'm going to try a wider tip, because the ground plane there is just sucking up too much energy. Alright, middle size, in between those. This one. Oh, and Phil in chat is asking what the iron temperature is. This is set to 750 Fahrenheit right now. And I was just struggling to change it because I just got this iron and I don't apparently understand the controls yet. Oh, here we go. Is that right? Great. Okay, I'm bumping it up a little bit. Okay, I think I know how to work the soldering iron. So more temperature, more tip. That seems to be doing it. Great. Oh, thanks. Phil in chat just mentioned how to set the temperature. It was the press and hold that I wasn't getting, but I eventually figured that part out. Yeah, this is a little bit grody for a demo, so I think I'll do this a couple more times and pick some slightly nicer footage, but this will totally be usable. Let's check out the other side. So, not terrible, but I'm going to want these to be shorter in the future so they don't risk shorting out. Oh. I guess the tip of these are broken off. Just noticed that. Probably have some side cutters somewhere that are in better shape than these. So, oh, that's not a good solder joint. How did that even happen? Was that just... Oh yeah, that third one is not connected at all in the slightest. Let's fix that. Let's clean that gross tip. Alright. Feel that hopefully sticking to what seems like both the wire and the... yeah, and the pad. I think I've got some molten insulation gook in the way that's keeping that from making good contact. That's better. Not perfect, but better. Much better. You can see the result of the wire wrapping. Alright, let's do a quick electrical test and then just try to... I guess I might as well epoxy it on. I mean, It's mostly just me going back and forth on how much I want to be streamlining the process versus trying to get illustrative documentary footage about it. Definitely will want some of each. So, I think now that I've soldered and inspected the backside of this, I can just put the board back in. Okay, these plastic pieces don't actually snap onto the board. They just kind of provide a little shelf for the board to sit on. And then the screws actually hold it the rest of the way in place. So, screws. Oh yeah, not screws, single screw. There was one screw, top right of the picture here. So I don't expect to have to undo any of the screws on the other cameras. Well, there's one screw holding this on and 3 screws holding the front circuit board on. Everything else is plastic snaps. Okay. Back side. So that's what we've got there. So guess I should just warm up the knife again. Oh, that's a good, just saw the suggestion from Kyle in chat asking whether this micro soldering handpiece fits in the original stand. And actually, I have not tried it, but now that I look at it, it looks like it's probably way too little. So, give that a shot. It is way too little. Way too little for that stand. So, although it looks like you could probably make some kind of shim that would fit in there, and then you could put this in there. I don't know if 3D printing would work. I don't know if this stays cool enough, but that might be an option. I guess they probably sell some kind of official stand for it. Alright, is this thing warm? It hasn't started smoking terribly yet, which probably means it isn't. Oh yeah, maybe while that's warming I can mix up some epoxy and we can get some epoxy footage. Although I would really like to test this before doing the epoxy, so maybe while that's warming up I do a quick test. So, the scope. Let's just hook the scope up to the new connector. Right, so let's approach this a little bit like a student would, since I've covered up all the labels apparently. So I want to plug this into power, and I'm seeing it draw like 700 milliamps and then settle down a bit. It seems to be booting. So now alright, so voltmeter between my external ground and these. Oops. That one's 3.3. Tell whether the noises are coming from my other things on my desk or from this. Oh, they are coming from this. Thought I was going nuts. That noise is, I guess, the filter switching a few times. Keep switching. Maybe it doesn't like looking at nothing like this. Anyways, we've got ground, low, high, VCC. So I think we just want that pin as ground, and this pin is probably the serial. Cheating a little bit because I kind of remember the pinout. Hot knife is starting to feel hot. Oops. Oh. I see the serial. Actually, This hooking this up to the scope is kind of silly at this point. Let's just go right to the serial adapter so then we can test both directions. Let's see, let me start the computer recording. Oh, this button, yes. Let's see if I know I installed the prolific serial drivers recently. Was that on this computer? I think it might have been. I think that's what this little adapter uses. Alright, so that's plugged in. Yeah, okay. So, now I also don't really remember the pinout for this, but I'm just going to look this up on Adafruit's site because that's easier than figuring it out. This one. So this provides power, which we want to ignore. Black is ground. White is receive in. Green is transmit out. Okay. And I need an extension cable because this thing is way too short. Doing this with the hot knife in the way. Alright, let's tape this down a little bit. Oh man, that tape dispenser is really sharp. Alright. Are we booting? Come on. Go, Minicom. How do I options? Let's unplug this for a moment. How did I break Minicom? Oh. Can I fix this by unplugging it and plugging it back in? I think these drivers are not necessarily the most stable things. Yeah, I think I have an unkillable process now, thanks to that. So I could reboot at this point, or I could attach this to a Linux VM. Let's attach this to a Linux VM. Do I not have a USB device? Oh, I wonder if maybe I shorted the ground to something? I mean, I think this is the right pinout, but let's try unplugging this for a sec and see if that restores our ability to communicate with this thing. Okay. Seems to have made my keyboard stop responding also because it's on the same USB hub. I think the USB subsystem on this Mac is a little bit hosed at the moment, so I think I might have to reboot this. Arg. Well, while it's rebooting, I can hot knife one of these cases. Sure. Don't remember making changes to that. Where's the front side? Come on, keep rebooting. You know you want to keep rebooting. Alright, so I'm just going to cut out a pretty nice big chunk of this case. So roughly using that as a guide. Relatively clean. The Mac has a black screen, and I wonder if it's actually rebooting. Alright, well, I think, is that Mac actually starting? Might hit the power button on it. Booting now? Okay. Starting to fill the pipeline. Yeah, no shit. Go away. Okay. Okay. How is my hotkey not working? I'm doing like escape A, O. Escape Z works. No, I guess I just want escape O. Sure. And I'm gonna guess this is 115/200 because that's what most people use. Flow control off, the usual. So, and let's plug these back in. Try not to burn myself on the hot thing. Just restart this camera so it doesn't stop itself. Alright, so black, green, white. And power. Well, let's try other baud rates maybe. I also measure this on the scope. I don't think people are going to have scopes in the class. Oh, that was it. So I just restarted the power. It's 57,600 baud. There's the bootloader. Raspberry read. Interesting. So let's see if we actually get a shell. That'll test communication both directions. A non-compliant UVC driver. Well, it looks like it has pretty standard Linux video drivers for the camera. This might be a fun little platform to hack around on. End of internet.sh. No pan tilt. Oh, and it drops you right into a root shell? Anyway, and there's a bunch of other stuff happening in the background and spewing log output here. It has top installed. UVC stream. It's not a bad little camera. It's probably terribly insecure. Yeah, there's no Etsy shadow. Yeah, so it's got some kind of hard-coded password. Anyway, so imagine this is the sort of thing that people are going to want to really have fun with and not have to do the soldering beforehand. But this is basically the kind of thing. So, I guess I'm just going to go put this one back together to have one finished. And then I want to do maybe one or two more individually just to try to get better footage, since I feel like this was a bit ham-fisted. But then I'll just try to kind of do them as fast as possible for the rest. So that's my current plan. So, yeah, this is nice. Couldn't tell, like, I could tell it was flipping that that filter in and out, but it was hard to tell whether it was doing it just because it was booting or because of some light level change or because of like some feedback loop caused by it pointing at the glass here. So I don't know. So I'm just gonna watch it boot again for fun. Can I talk to the bootloader? Bootloader command line interface. Yeah, it runs U-boot. Neat. RT3352. How much memory do I have? Oh, that's actually just dumping memory. Cool. Can I get the memory map? Well, this knows about the SPI flash. So yeah, I guess this is, it looks like the way the board is designed, maybe the previous version had those big parallel flash chips that I seem to see in the photo from my coworkers, but it looks like in this version they have what looks like just an SD RAM up here, the application processor, and then on the other side there's that little SPI flash. So that might be what the actual firmware is installed on now. This can boot from the network. It's neat. Or from serial. Start HTTP server to load image. I wonder how well this handles network configuration and all that. Let's just see what that does, just for fun. I don't even have this plugged into Ethernet right now, but this runs some kind of embedded HTTP. Tells me what its IP address is. Bootloader HTTP. Well, this will be fun. I'm not going to get too deep into this. We know it works, which is all I really need to do right now. So let's put this one back together. And I'm maybe going to take these connectors and kind of Kapton tape them into position just so that it's easy to plug this into the new devices to test them. Just going to bundle these up slightly. Blurry. So, made a little connector to plug in. Anyway, got this step. Oh, Tuco's looking good, as usual. So, and then we've got our mangled case here. So, go ahead and put this back on just so I don't have to worry about doing that after the epoxy cures. I keep feeling like I'm missing something, but it really just was one screw, and then this snaps on. I think I broke this particular snap, but that's fine. And even without that corner snap, so I lost a couple of snaps due to the carnage over there, but it still seems to hold together fine. So let's do a little epoxy. I don't want to do too much like individual epoxying, but actually I guess I'll save this epoxy until I've done at least a couple more, because the footage isn't really going to be any different for like epoxying one versus epoxying a few. So I'll put that one aside. And that one still needs epoxy and a final test. But I've got this one. I'm also going to put this one aside because I don't necessarily want footage of the process where I cut into it first, since that's not really reflective of what people would be really doing. So I'm going to keep this, but put it aside. And open up a third one. Somewhere there's a knife. Not the hot knife, just the regular knife. Hot knife through cardboard probably wouldn't work super well. Yeah, there's some good discussion in the chat. Sodium mentions that there are some, if they remember right, there are some routers that you can root just by putting a TFTP server on the same network and then rebooting them. That's an interesting class of attack because it really, it directly hits the stuff that makes, where they're trying to make Internet of Things devices convenient. Because really the whole setup process is super difficult to get right in a way that's both secure and convenient. So, like, there have been several cases where, you know, there's this device that is normally relatively secure, but if you can force it to go back into its initial like one-time setup mode, then it will just kind of, it'll let you be its new master basically. Oh, looking for my spudger. All right, so another fresh camera here. I'm gonna spudge this one open and do the circuit board mod outside the case for visual effect. So yeah, I think this thing wedged down there in just the right places will actually open it on its own. That side. I think we got it. Oh, top side. I mean, I could take it apart anyway, but that would be more likely to break the snaps. So, there we are. Clean entry. And let's go ahead and take this off just to show the labeling on the circuit board on the other side. There's going to be a lot of deja vu here, but just repeating it to get more footage. Oh man, I need a better place for this hot knife where I have not burned myself with this yet today or in recent memory, but it feels like I'm getting so close all the time. Let's try that. That is one beautiful little cat. Appreciate the zoom on this lens. All right, so there's that. Then we can do that. Well, it'll be nice to have some B-roll from me kind of poking around, not having any idea what I'm looking for, because that's also pretty reflective of the actuality of the process. And a little bit of microscope from that to this one. Yeah, it definitely would be kind of a little JST style or some other similar little box-shaped pin header connector, but the pitch is a little small to be convenient there. If this wasn't necessarily a didactic exercise on its own, then it would totally make sense to just manufacture a bunch of little connectors that just do exactly what you want, but that isn't usually what people are going to be doing, since usually you want to do something that's one-off. So, and looks, at that point I think I kind of want to ignore the bottom side of the board and just focus on this top side. So, that does not hold it very securely, does it? It's fine. Alright, so that's that. And I guess we just need to get some wire wrap footage to go with this too. Little pieces of wire, So I'm also going to try to just cut the wires and strip them ahead of time. I want them to be pretty short, hopefully all the same length. So I can do more of a large-scale wire cutting operation in a sec. No need for the solder pot, at least, since we've got the wire wrap technique. So, good old Kynar insulation. So one of these ends I'm going to actually strip really short, so it's just really enough to solder in without having any risk of shorting on the opposite side. The other end you actually want to leave somewhat long for the wire wrap tool to work. So that would be like the minimum I would leave. So let's just do that a few more times. Slippery stuff. Tried to pull that apart and the wrong end of the wire came off. I have an automatic wire stripper that would be really nice for this, but I don't think it works well on wire this thin. This definitely feels like it's way more annoying than necessary and would benefit from a different technique. Anyway, so I got 4 of those little wires that look kind of terrible. Little things. For any of you who haven't seen a lot of wire wrapping before, it's definitely an interesting art form to check out. This used to be a pretty common, albeit really tedious way of making large kind of prototype circuits. You would get all of these integrated circuit sockets and other sockets that were designed with these long square pins, and you'd use a tool kind of like this one to securely wrap little pieces of wire. Well, usually not little, but the same gauge. Usually it was 30 gauge with Kynar insulation. So it's still useful for the occasional weird kind of patch, but not usually something you would wire an entire circuit in these days. Alright, got those 4 wires. think this wants the microscope. These look a little long still. I might want to make sure that they, well, I mean, I might pull them up just a little bit so that I have a little bit more room to solder. This wire is so thin it can actually pass through the holes. Ground plane. Yeah, I can feel the other side of the board even heating up quite a lot from this. So that one will require some extra attention to make a good connection. That looks good. And let's do another case mod and then put this one back together. I'll leave the hot knife next to the fan right after using it, you know. Alright. I think that makes 2 of these ready for testing an epoxy. Which seems like things that I can do in close proximity to each other. And I can see through the side, actually, that the wires aren't shorting. So you can see the wires go through the board where they're soldered on top, and then they poke through the bottom, and they're still separate. They're a little long, but not problematically so, really. So that seems fine. Well, I think I'll do one more kind of like that, just to have the extra footage, and then I'll maybe do a couple at a time that are where I'm not opening them at all. Now, I should try not to destroy these plastic or the boxes too much, because I will be reusing them. Alright, one more. Let's open this one. Some more opening footage in case I need opening footage for things. Other side first, maybe, before the top. Come on. Glad I'm not committing myself to opening all of these, I think. So I think this is going to be easier to do without having to open them all. So this time I'm going to not bother taking out the circuit board, but just do the soldering on the top like this. Myself yet today. Alright, wire time. Make these slightly longer, just so that they're easier to strip. Alright, 4 wires. Wires are even hard to pick up when you drop them, on account of being so little. And I think grabbing these on the other side with pliers will actually help. It's really easy to nick the wire a little bit with the pliers this way, but I don't think I'm going to actually damage these in a problematic way. I'm just going to be squishing the insulation mostly. That's not what I wanted. actually. Alright, and wire wrapping tool, and header. No servo. This wire wrapping tool just barely still works with the hole kind of clogged. I think I've got another one around here somewhere. It's been ages since I've used one. Oops. Also, wire wrapping while keeping things on frame is not a skill I'm used to. And so when you do this properly, the wires are actually very tight. They get a good electrical and mechanical connection. I might have to get up and move the camera. Alright, another 4 of these wires, nice and tight. I'm gonna adjust the Chuco cam. Okay. One of these is way too long. Let's fix that. Also still not sure whether Kynar or magnet wire is going to end up being overall faster if I get out the solder pot for tinning. Because if I can tin magnet wire very fast in the solder pot, then, I mean, I still have to solder it to this header, but that might be faster than wire wrapping it. This one is shorter than the others. Solder a couple of those, maybe. I don't know. The easiest thing to do would be to solder one of them and then move the others into position. Don't know if that's what I want on camera necessarily. That's the hot knife, living up to its name. Let's move that. Gotta reset my number of days without a burn counter. Oh. Oh no, I've scratched the solder mask. It will no longer be a perfect glamour shot of this terrible soldering operation. I think this is just annoying because the wire lengths are not as even as I would have liked. Come on, ground plane. Seems fine. Alright. So that's another one to test an epoxy. Oh, after I cut the case. Fan is only sort of working. Oh, I've got a missing screw here. Did that go... Is one of these circuit boards missing a screw, or did that come out of something else? I think those are fine. Anyway. flat pile. Let's make an actual pile. Okay, so next step is to start parallelizing a couple of these where I'll just kind of cut open, you know, maybe I'll try just doing like 4 of them at a time and see what that feels like. Three more cloud cameras. It feels really good to inspire other people to put YouTube videos out there. I feel like that's one of those things that goes around a lot. Like, you know, I was certainly inspired by a lot of what I saw on YouTube, and it's nice to kind of pass that along. We can all be inspired by each other. It'd be really easy to modify these and then put them in the package and not really have anyone notice that they've been modified. Wow, this one's tripod is on super tight. Why? There we go. Scratch the paint. Oh no. Yeah, if you want nobody to know you've been in, maybe don't, like, scratch up the paint a whole bunch with pliers. I mean, usually the way these things work is the security researcher has to buy a bunch to figure out how they work, but then you find ways to get in and modify them without even having to touch the hardware. So physical access is pretty much the big hammer, where if you have physical access, there's some way for you to get into the device. It might be super complicated and not worth your time, but it's going to exist. But then there might also be other ways in, and so you can use that physical access as a stepping stone to find other routes into a device. So basically the same thing here. I'm a little nervous about going in there with the circuits, but there's nothing really heat sensitive on that part of the board. Where is that still connected? Feels like it's just barely hanging on there. I think there's an order to this because the way the stresses in the plastic work, if you cut the wrong one first, it just kind of wants to reseal. I think that's what happened. There's that again. So let's try to do that to 2 more cameras. This wants to come off. This just screws in like, it's basically the cheapest soldering iron you can imagine with an even lower quality tip on it that is just really flat. So if you have a soldering iron you don't like, I'm sure you can use that to do this kind of technique too. Just definitely make sure you've got ventilation because it produces all sorts of burning plastic vapors. Maybe I can get some of this under the microscope next time. Cut a little more into the front on that one than I really needed to, but it'll be fine. Alright. It's actually kind of tempting just to kind of keep going with this process, but I want to at least test a small batch just to make sure there isn't anything I need to change before just cutting all of them the same way. So, 4 of these. Still debating whether to do solder pot. Well, still torn between doing the kynar and doing the magnet wire. I kind of feel like keeping going with the kynar. You know, I'm going to give this a shot with the automatic stripper, because if I can make that work, that would save a lot of time. So this thing is pretty awesome. I don't think it's designed for 30 gauge wire, but maybe we can give it a shot. So it just cut the wire right where it was supposed to be stripping it, so I think it's a little too forceful. And that's on the minimum force too. Well, man, this part is super fiddly. I really don't like this part. Maybe the solder pot is next. Also, I think these are too short. Let's not have them be quite so unusably tiny. So just folding this wire a little bit so I can cut a bunch of pieces that are the same. This wire is so annoying to strip. It's even kind of tempting to use uninsulated wire for this, although that seems like also a recipe for annoyance. Oh, this just keeps cutting when I try to strip it. Oh. I feel like I should at least try the solder pot. Like with the solder pot, it'll be really easy to tin a bunch of wires all really quickly. And soldering them to these headers might actually be faster than doing the wire wrapping. Okay. Well, man, this hot knife smells so gross. I think, yeah, maybe just to limit the number of crazy tools I have going at once, I'm just going to try to do as much hot knife cutting as I can first, and then I'll warm up the solder pot and do a bunch of tinning and see how that goes. And I mean, I'm making footage-related decisions again. I think I don't need to worry about any kind of... I guess I'm thinking about whether I need to save some of these to do with the magnet wire, but with the circuit board removed from the case, I don't think I care. I think I'm just going to go for it. Let's organize this a little more. Okay, so I've got all these. So I'm going to put these aside for the moment. And just start parallelizing as much of this as I can stand to. So there's a lot of opening. Really get into the kind of repetitive aspect of this, I guess. Just do one thing and keep doing it. Okay, let's take some of these apart. Did that not actually cut through? Huh. Happening. How did that not cut all the way through? Am I failing to use an X-Acto knife? There's like a little tiny piece. Use a spudger to open this without ripping it. Oh, there's a good question in chat about whether I could add more context to the video descriptions. That's probably something I should do. I've been feeling a bit overwhelmed by the kind of social options available, and so far I've just been leaving the descriptions the same, but having a title on the YouTube videos, but I often don't even edit the titles on the Twitch videos. And yeah, I think I should set up some kind of bot to make that a little more automatic and possibly allow some crowdsourcing. One more. Oh, there's still so many of these. All right. Smells like the most misbehaving 3D printer. All right. And the box. Burn a hole in it, throw it in the box. Ooh, I'll do the next one under the microscope. I forgot about that until now. This is fun looking. A little hard to keep an eye on what I'm doing and also make sure the microscope's in focus, but the footage looks fun. Neat. And the box. Actually, it smells more like a laser cutter than a 3D printer. Since, 3D printers usually don't quite get this hot. Good junk. Sometimes I get worried because I see the hot knife in the microscope view coming toward my hand, but then it's like, no, actually it's like 4 inches to the right of my hand. It's just that that's where the monitor is pointed. And the box. Molybdenum wire. Joel in the comment says molybdenum wire is great for this. I'm curious if that's for the cutting or for the soldering. Never heard of molybdenum wire. Don't know what you would use it for. Imagine someone who really needs molybdenum wire going around at Noisebridge asking for Molly. Gotta have some molybdenum wire, dudes. Really need it for this party. One more of these opened, and then I guess I'll open some more. And that microscope footage was fun. Smeared plastic across the circuit board that time. Oh, I didn't check what kind of plastic this was, but it smells like ABS. I'm not super worried about the fumes, though. I might open a window in a sec, but this place is so drafty that it would take a lot for that to really build up. That's maybe a little too loud. A little bit of airflow in here. Ooh, some of these are really too grippy. Man, what do they attach these with? Like a torque wrench or something? Probably not. Maybe it's just really not a good piece. Sheesh. I guess I theoretically don't actually have to take this part off. It just seemed easier since, for the most part, these... I'm just gonna get vice grips. Wow, they're advertising. This must be a really low-end camera too, because they're advertising it as VGA resolution, which is, I don't know. That's like a weird thing to put on the package, because if you know what that is, you probably know that it's not very good. But if you like don't really know what you want and you just want a cheap camera, then like, I don't know, maybe they just want to saturate people with buzzwords. Okay, that did it. That really shouldn't be that hard to get out. I was afraid I was going to... Ooh, yeah, this was like... I think this was like severely cross-threaded at the factory, because there's all sorts of residue in the brass insert. Oh well. That one's not getting a 5-star review. Yeah, I don't actually know the full details of the class. I just kind of had a brief description of what it was about. But it sounds like it's like a really short one, so that's part of why, normally this is something the student could do, but like my coworkers are teaching a shorter than usual class, and so it's going to cover kind of the basics of getting in and making your way around like an embedded Linux system like you'd find on a router or a connected camera or pretty much anything else these days that people are manufacturing. So yeah, I think it's only like a few hour long class, so they have to be pretty choosy about what the material is. Aw. Thanks, Tuco. Oh, is this one also on really tight? They just have the machine doing terrible things to these at the factory that day. Oh, this one's not nearly as bad. Yeah, the wire stripping is super annoying the way I was doing it. I think solder pot plus enameled wire will do the trick. I mean, I'll have to worry about dipping the wires in flux, but that should be fairly straightforward. Alright, I've opened all the ones on my desk. I'm going to do another round of cutting now. Oh, my floor is covered with boxes. Here's where the finished ones are going. Well, not finished, but that's where the ones that are finished with the step go. definitely a trick for the kind of rate and angle that you go through at, because sometimes the molten plastic can just re-solidify right behind the tool. But if you go at the right speed and everything else is just right, then it can kind of stay open behind you. I watched a couple of those like 1,000-degree knife through whatever videos, and they were kind of disappointing. Like, I think it's one of those things that sounds like a great title, but then it's like, well, what did you expect? It's just a little piece of metal. Or, I don't know, it kind of reminds me of I feel like there's this whole category of clickbait videos out there that only really make sense if you don't know if you don't really know what to expect. So like, oh, there's this experiment we're gonna try, but it's like, I don't know, I can't think of a good example off the top of my head, but it's like the kind of thing that becomes clickbait when, I don't know, when the answer isn't already apparent. Then I guess this doesn't really work without the example, since it was the example that made it seem so ridiculous at first. Oh, Tuco. He was just in that box checking it out. I don't know, humans are pretty weird. Like, whatever this meta-organism is that the humans are turning into is even weirder. And it's like hard to know even how to think about that, because we're simultaneously part of it, but also kind of at odds with it. Oh yeah. This smell definitely reminds me of badly vented laser cutter. But that would imply acrylic, but I doubt this is acrylic. It doesn't seem brittle like acrylic. It's probably just ABS. Hey Tuco, I feel you rubbing my leg. Oh man, I got some treats for Tuco that are so gross, but he likes them a lot. They're like freeze-dried sardines. Should give him one of those, maybe. Hey Tuco, what do you want? Where is he? What's up, Tuco? Can't always understand the cat. Seems like a pretty rare situation, but it's nice when it happens. Oh, I was noticing Kyle in chat was asking if I've read Gödel Escherbach, and I actually have not. People have recommended that to me before. I've found that I have a pretty abysmal attention span when it comes to actual books, but not so much when it comes to audiobooks. So I think most of the reading I've been doing lately has been like a couple of William Gibson audiobooks, but yeah, I should check that out. I feel like I've got a really big hole in terms of knowledge of, like classical philosophy or anything along those lines. Oh, I was bothering to line this up under the microscope, but then I didn't bring that in front. So weird. For all of you on the internet who don't have to smell this, it probably is easier to imagine that this is like frosting or something. On this end, even with the fume fan running, it's pretty clear that this is plastic. Hey Tuco, you got a bolt? He so has a bolt. Yep. China's a good landmark. I hear you, cat. Just a sec. I'm in the middle of a thing. Delicious. Alright, more to open, I guess. Cleared off the desk again. That's a nice feeling. Gotta open some more cameras. Oh! Thanks, Tuco. Oh, neat. Kyle was mentioning there's a story in Gretel Escherbach where there's a sentient anthill composed of an organization of non-sentient ants. That's interesting. I think I would find that very fascinating. I feel like there must be all these different time scales at which you can you can look at the entire universe. And at some of those timescales, humans seem pretty interesting, and at some of those timescales, humans probably just seem like neurons in something else that's probably much more dynamic. But, you know, at a much slower timescale. And so all these, I don't know, we've got all these concepts of morality about what we think we can do that's good for the larger whole, but then we also kind of, at some level, don't really have any idea what that larger whole even is. And, you know, I still think people should generally be nice to each other. It seems to work out. Yeah, that cat's great. And that's the box with the mostly finished ones. But they'll still need testing, so. The stream feels so much easier than most of them because I already kind of know what I'm doing. I'm used to doing stuff that I've never done before on camera. And not that I've ever done this particular thing, but it seems like so close enough to everything else, or to other things that I've done a bunch of times, that I'm not worried about it. Most of these are screwed on to a perfectly nice level of torque. Maybe they put them on by hand at the factory, and the person who normally screws them down was like taking out their anger on the device that day. Oh, there are 6 of these not yet opened. This is going relatively fast. I mean, we haven't really done the hard parts yet, but... I mean, I guess there aren't really any hard parts, just parts. Incoming toque. Well, the fresh air from outside is nice, even if it is a little chilly. It's been raining so much here. I kind of, like, there's that blue cloud thing that also kind of looks like the Skype logo, and it's like, oh, do these have built-in Skype? Or is it just some other, I don't know. I still can't think of, I mean, cloud just, I can't keep a straight face when someone talks about the cloud. Because there are so many other things that are equally meaningless that my mind just substitutes. I don't know, I think the most meaningful thing people have said about the cloud is that there is no cloud, just other people's computers. And the cloud is just a word that people make up to obscure the fact that that transaction is going on. I mean, I guess it also kind of fits in with this notion of how, like, people generally don't really administer their own systems anymore. They're effectively administered by their operating system vendor. Yeah, the cloud to butt Chrome extension, as Kyle mentions, is quite good for this. I also like thinking of the cloud as the clown. It's like, oh, we'll just store all the files in the clown. But I mean, I feel like that's kind of a diss to clowns, because clowns are actually much better, I think, than the cloud is. I mean, I don't know, I used to not really have much regard for clowns, but then I saw a couple of Cirque du Soleil shows that had these clowns that were just, you know, like, I mean, sure, they were funny, but even more so than that, they were telling a story that was kind of accessible in all these different levels, and also just kind of mind-bogglingly human, and then I kind of saw the purpose of clowns as to be this kind of not so serious way of showing some of the most serious sides of human nature. And so yeah, clown, much cooler than the cloud when done right. Because even when the cloud is done totally right, then it's still someone else's computer, and they might just decide to shut it off at any time and take your data with it. I think I just opened the last box. So they're all off camera. How did that happen? So alright. Ooh, now I've got a big empty box over here, which I wonder if Tuco is going to find appealing. Alright, more cutting. More cutting. I like how this cuts through the sticker without pretty much even noticing. You know, I've heard that expression, like a hot knife through butter, but I've never actually tried cutting butter with this. It seems like it would leave the butter kind of gross, so I think I'd rather not. And I mean, this cuts pretty well through plastic, but I don't think it cuts well enough that people are going to be using this as an exclamation. Like, wow, like a hot knife through plastic. It's like, well, yeah, it gets there, but it's nothing to write home about. In the box. I've often wondered about having a... Also, this is in reference to another comment in chat from Fedor, who says, at one point in the past, I remember there being a truly decentralized storage app that shared your files on a bunch of clients, like a torrent-powered Dropbox. And that sounds pretty neat. I've often been curious how far you could get on building a file store based on like other people's free storage. So like URL shorteners and Twitter accounts and open S3 buckets and just anything else you can find on the internet, and just get as much of that as you can, and then store your files in a way where you have kind of a decentralized index and you have a lot of redundancy. I'm curious, I mean, it would be super slow, I imagine, but probably pretty effective for short documents that are well encrypted and yeah, so actually there have been some questions about the context, and so in this case the pile of cameras is for a class where some of my coworkers are running a basically like an introduction to hacking, or kind of getting even kind of getting your bearings in these small like embedded Linux devices. And so this is basically the first step that the students would normally do in a longer version of this class, and kind of, they would solder stuff to the board, but in this case we're preparing for a shorter version of the same class, so in that case I'm doing the prep ahead of time so the students don't have as much work to do. And this was made slightly more exciting because apparently the board has revved since the ones that my coworkers looked at last, so the connector we're attaching to is slightly different, but still your basic 3.3 volt serial. Although, I do actually have my own big box of cameras in my in the back of my closet. I found a really good deal a while ago on the PlayStation Eye cameras for like $7 each, and so I bought a box full and used them for some classes, but I still have a bunch left over. And they're kind of nice because they have a, I think it's 160, or no, like a 240 frame per second mode, something like that, at kind of a low res. So for a cheap camera that has pretty, has been pretty well reverse engineered and community supported at this point, it's pretty nice. So I don't know, I had ideas for a lot of projects involving those. I ended up writing just some tools, like I wrote this thing called Speedy Eye that was basically a way to use that in a class that was based on processing without having to have people like compile their own C++ code. And I've thought about doing some mods for them so you could trigger, like have a bunch of them synchronize their frame capture, which would be kind of nice. I was thinking about doing something where I just connect, well, I guess there were a lot of different project ideas there. One thing I wanted to do was to try to synchronize coded IR illumination to the frames on that camera so that I could do some kind of spatially modulated IR light that would transmit like 1 bit of information per pixel per frame, basically. And then so I would get a frame sync signal from the camera's SoC. There's something else I was thinking about doing with just like syncing the cameras to each other, but there are probably a lot of really easy ways to do that. What's up, Tiger? Duco, this is a box. All right. 7 of these left to cut. I can't imagine him not exploring that box. be good for very brute force cleaning up of your 3D prints if you have absolutely no desire for them to look good. Facebook file system. Yeah, that would be funny. And then they would try to data mine your, like, presumably stuff that wouldn't make any sense once it's in the format that they have it in. I'm all for injecting more uselessness into whatever data they're mining. But that's certainly an uphill battle. I still feel all the weird feels about Facebook, because that was one of those companies I came close to working for. I mean, I don't think I ever really was interested in working for Facebook, but a lot of my peers for a while were jumping ship from VMware and going to Facebook, and I didn't really understand it at the time, but I kind of got a little bit of a taste of their enthusiasm, and it didn't really lead to me being enthusiastic about it in the slightest, but it mostly just led to me being confused. It was like, I don't know. Like, I think some of the enthusiasm was for, like, helping people connect with each other, which is totally a thing, but there's a lot of ways to do that, and, like, owning the way that people connect with each other is kind of a perilous position to be in. And then, I don't know. A while ago, they wanted me to work on something for them that was going to be, like, I don't even know what that turned into, but basically they wanted me to do some graphics programming for them. Something that sounded like their own game platform. And couldn't find a way to make that worthwhile. It was just one of those weird little mental gymnastics. Like, I've got people in my life that I thought I had a lot of respect for that think this is a really cool way to spend time. How do I empathize with that point of view? And I don't think I've ever really gotten there. But there's this weird thing technology does where I think it's easy for something that is just like a very general aspect of either the technology or the way things work in the world or the way humans work can start to feel really specific to the particular company or technology that you're working with. And I think maybe some of that's going on. Like, there's this thing that is large-scale human connectedness, which is interesting, but then the process of, like, packaging that as Facebook kind of starts to take on the aspects of this thing which doesn't actually really have anything to do with the Facebook platform. And then it's more like, I don't know, it's like people squatting on land. It's like, we got here first, we find this land to be very valuable, therefore it's ours, and we're going to sell it to people. And so it's like that. It's like, you know, I feel like discovering social networking was kind of like this new kind of plane of business that no one had seen before, and I don't know, Facebook is still in this stage of just kind of being first to make a big thing there, and they haven't yet imploded. But I don't really see anything special about what they're doing. Oops. But I guess people were at VMware for a lot of different reasons, and I think the kind of person that would have left VMware to enjoy Facebook is probably, like, they were probably at VMware for very different reasons than I was. Yeah, I still kind of struggle to, like, how do I do that empathy? How do I get inside the head of the people who still work for this company that seems to be just really bent on just kind of grinding up people's lives and turning them into fuel for a big advertising engine, and now is also kind of politically dubious? I don't know. We just have a conversation about it, but I'm not really close with any of those people still. Had lots of moments in life when lots of things changed, and I just had to kind of pick up everything and figure out how to have a new life, and each of those little cataclysms ended up shedding quite a lot of friends. Often for good reasons. Sometimes it just kind of worked out that way. I had this friend for a long time, and, you know, things were like alright. We didn't necessarily have that much in common, but we were college roommates for a while, and then, like, things were, like, we weren't really close for a long time, but there was kind of a tepid relationship that was alright, which is kind of how things go. And then the thing happens that just, like, breaks it all, and it was like, you know, he's getting married, and lots of, I mean, basically his fiance ends up saying some really nasty things to me, and so I'm like, I am done with you two. And then he eventually apologized, but it was one of those things that was kind of hard to recover from. And I guess I've realized since then that so many of the friendships in life are just situational, that, you know, you put people in the same room every day and have them subjected to the same issues, and they're going to bond over that, but then take them out of that, and then they're just kind of regular individuals that may or may not see eye to eye on anything at all. Oh, I meant to have this on the microscope, sorry. Second to last one. Yeah, Kyle points out that it's very easy for people to get caught up in solving a problem. That is exactly right. That is something I feel like I've been, I don't know, just like allergic to my entire life, because it's something I saw a lot in my dad, and then my brother kind of followed in the same footsteps. My dad had this long career in aerospace where he did some things that he liked and a lot of things he had no interest in whatsoever, and it just didn't seem like he felt like he could choose what he does with his life, which, you know, a lot of people can't, or at least can't completely, but I mean, everybody can to some extent usually, and just seeing that kind of defeatism, I think, in him kind of galvanized me against it. And then I saw I have a younger brother that I don't really talk to. He and I haven't been close in a long time, but then he pretty much followed in my dad's footsteps and got a job at the same big company and doing kind of morally dubious stuff, and so I had a Dremel here too, which was my second plan, but this is actually, I think this is actually much easier than the Dremel would be for the same plastic. Like, the Dremel would fling chips everywhere, and it would also melt the plastic a little bit, not quite this much, but whereas this puts off some fumes that are relatively easy to vent out and looks a little gross, but otherwise is fine. Alright, I think that's the last cut. Unplug this hot knife. tube goes off to? Oh, tube goes way over there. So much stuff on the way. Okay, I guess the next tool decision is I should see if the solder pot actually makes it easier to do the stuff with the wires. So I guess I'll bring the solder pot over here. The solder pot itself is also kind of a scary object, but tidy up the space a little bit. No, Tuco's under the desk again. Alright. I think this is cool enough to put it on another desk. Alright, so keep these. Okay. Oh. Oh, such a good cat. All right. Let's put the glass away, but keep the metal. Alright, here's the solder pot. So I think I'm realizing that I'm actually hungry, which is a thing that happens occasionally, and then even less occasionally, or even more occasionally, I recognize this fact. So I think I might take a brief break from this to get a bite to eat, but I will plan to be back on the stream this afternoon and start back up with this. So let's give a little context for where we're at so far. So there's the box they came in. There's all the packaging and parts that we're not modifying. Let's see, that box with just a couple over there. Those are mostly done, but they need epoxy and testing. And then, oh, sorry, Tuco. And then this box has all the ones that have been cut, but no other modifications. So I think that is the stopping point for right at the moment, but I will be back after I am no longer in a state where my stomach is continuously trying to eat itself. Oh, good question from the stream. How do I keep Tuco from the solder pot? By being, well, by being near the solder pot anytime it's on, for sure, and by keeping Tuco off the table. I mean, he usually doesn't just like jump up on my table and like get in the hot tools, but I will have to be cautious when I use it. It is one of the more dangerous tools I think I have here. Like, if you use it correctly, it's pretty safe, but if it spills, that could be pretty bad, so. My solder pot, at least, is a really little one. It has this little crucible on the top where the solder melts, and then a big kind of insulating column, and then variable power supply at the bottom. So, it is a weird object. I don't know why it's American Beauty. I can only imagine that that name is kind of sarcastic, like so you're disfigured after like burning yourself on the solder pot, and the solder pot is American Beauty. I don't know. Hey, Tuco. Oh, somebody in chat brought up the sardines. Maybe I can give Tuco a sardine before I end the stream. I know. Whoa, you're so sharp. Me too. Little guy. Little cat likes his dead fish. All right, thanks for tuning in, folks. I'll be back later with less hunger.